So in this video, we're going to talk about how to write 3x3 systems of linear equations. So we're going to be using the first two parts of this problem-solving process today. So we're only going to be understanding the problem and making a plan to solve. We're actually going to do the solving in a later video. So for today, we're going to start off by trying to figure out what it is we're trying to solve and make sure to underline, circle, or highlight important information. Then we're going to work on defining our variables. After we do that, we're going to make a plan which is going to involve setting up the equations that are going to form our system. So this chart that has the words and phrases that represent math symbols is going to be very useful to us because whenever you see these words or phrases in your problem, you want to make sure and underline or circle them because they're going to give you an idea of how to set up your equations. So what we're going to do today is we're going to start off by reading the problem carefully and look for any important information. Then we're going to define our variables and write equations that represent the situation described in the problem. So let's look at this first example. A wholesale bakery offers pies, cakes, and tarts to area restaurants. One restaurant orders 4 pies, 3 cakes, and 2 tarts for $57. A second restaurant orders 5 pies, 4 cakes, and 3 tarts for $76.50. A third restaurant orders 1 pie, 2 cakes, and 3 tarts for $40.50. Determine a system of equations to determine the individual prices of a pie, a cake, and a tart. Okay, so let's start off by figuring out our variables. So I'm just going to call our variables in all these problems x, y, and z. Okay, so we want to find out the prices of a pie, a cake, and a tart. So I'm going to say x is the price of a pie, y is the price of a cake, and z is the price of a tart. Okay, so we have our 3 variables, our 3 unknowns that we're trying to find. So now what I did is I took those sentences that I highlighted when I was reading the problem and I wrote them out separately. Okay, so I wrote them out separately so I realized that each of these sentences is going to be an equation, right? So if I look at them separately, I can write my equations without getting confused. So 4 pies, right? That's like 4x. And then I'm going to put these all together, so I'm going to use my plus signs, right? 3 cakes would be 3y. 2 tarts, so that's going to be 2z. And then it gives me like a total, right? So remember, whenever we have like a total value, we're going to write an equal sign. So we have that equals 57. Okay, so let's work on the next sentence. Okay, so 5 pies, 5x, plus 4 cakes, 4y, plus 3 tarts, 3z, and that equals a total of 76.50. Okay, so that's my second equation. So now we have a third restaurant, so 1 pie, so you can write 1x or you can just write x, right? And then 2 cakes, so plus 2y, and 3 tarts, so plus 3z, and then I have a total, which is $40.50. Okay, so you can see now I've set up my 3 equations, right? I have my 3 equations in my system. So just to kind of summarize, I'm just going to write all my equations with all that extra work there. So I have 4x plus 3y plus 2z equals 57. And then I have 5x plus 4y plus 3z equals 76.50. And x plus 2y plus 3z equals 40.50. Okay, so you see what I've done here is I've taken this whole word problem and I've translated it into a system of equations. So now let's try this example. Last week the circus sold 1,000 tickets. The ticket prices are as follows. A child ticket costs $5, an adult ticket costs $10, and a senior ticket costs $7. The number of child tickets sold was twice the number of adult tickets, and the total ticket sales was $6,750. Write a system of linear equations to represent this situation. So first we want to think about what is it that we don't know in this problem. What are the unknowns that we're trying to figure out? So we don't know how many of each type of ticket was sold. So let's let that be our variable. So x will be the number of child tickets. Y will be the number of adult tickets. And z will be the number of senior tickets. So now let's work on setting up our equations. So what I did is I took the important information that I highlighted here when I was reading the problem, and I took it apart so that we could set up our equations. So it tells us that last week the circus sold 1,000 tickets. So 1,000 is kind of like a total, right? So all together, if I put together x plus y plus z, that's going to equal a total of 1,000. Then it says that the number of child tickets sold was twice the number of adult tickets. Well, child tickets is represented by x. So if that's equal to twice, remember twice means 2 times the number of adult tickets. So 2 times y. And then we have the total ticket sales was $6,750. So here's another situation where we're talking about the total. But I want you to notice the difference between this equation and what we're describing in this equation. Because here we're talking about just the total number of tickets, right? So how many actual tickets were sold. But then here we're talking about the total amount of sales. So when we're talking about the total amount of sales in terms of dollars, we need to factor in the price of each ticket. Okay, so instead of just adding together x, y, and z, we're going to multiply each variable times the cost. So for example, for child tickets, we do 5x because each ticket costs $5. For adult tickets, we do 10y because each ticket costs $10. And then for senior tickets, we do 7z because each ticket costs $7. And that's what's going to equal the total of $6,750. So that can be a concept that's a little bit confusing when you're working on setting up these equations. So I want you to make sure that you understand the difference between the total number sold and the total amount of money that they're earning in ticket sales. So let's just summarize our 3 equations here. So we have x plus y plus z equals 1,000. And then we have the number of child tickets, x, equals 2 times the number of adult tickets. And then we finally have our cost equation. So 5x plus 10y plus 7z equals 6,750. So now let's try this example. So Declan, Josephine, and Maria decide to have a swimming contest. So together they swim 100 laps of the pool. Josephine swims twice as many laps as Declan, and Maria swims 2 more laps than both Declan and Josephine swam. Formulate a system of 3 equations to represent this competition. So what don't we know? What are our variables? Well, we don't know how many laps they did individually, right? We know how many laps they did all together, but we don't know individual laps. So x, let's call that Declan's laps. And y, we're going to call that Josephine's laps. And z is going to be Maria's laps. Okay, so now let's take those sentences that I highlighted and let's turn them into 3 equations. So together they swam 100 laps of the pool, right? So together is like all together, total, adding everything up. So we're going to say x plus y plus z equals 100 laps. Now we have this Josephine swims twice as many laps as Declan. So there's one of our important math words, right? Twice. So Josephine, the amount of laps she swam, which will be y, is twice as many as Declan. So that's going to be 2 times x, right? Because Declan swam x laps. And then we're going to say that Maria swims 2 more laps than both Declan and Josephine swam, okay? So we have another one of our math phrases here, right? 2 more laps. So 2 more is going to be 2 plus, right? So Maria is z. So z is going to equal 2 plus the amount of laps that Declan and Josephine swam. So 2 plus x plus y. Okay, so now we have all 3 of our equations. So we can just write down our system. So x plus y plus z equals 100. And then we have y equals 2x. And we have z equals 2 plus x plus y. So now you can go ahead and pause the video and try doing this example on your own. So in this problem, it says that Ahmed collects train toys. His collection is organized into 3 types: wooden trains, metal trains, and plastic trains. His collection currently has 200 trains. He prefers metal to wooden ones, so the number of metal trains he has is 7 more than twice the number of wooden trains. He has 22 plastic trains in his collection. represent the situation as a system of equations. So what don't we know? We don't know the number of individual trains he has, right? We don't know how many wooden, we don't know how many metal, and we don't know how many plastic, okay? So those are going to be our three variables. Well, we know that all in total he has 200 trains. So that means that x plus y plus z is equal to 200. The next sentence, the number of metal trains he has is 7 more than twice as many wooden. So I really like this sentence because this is a very mathematical sentence, right? So we can just directly even translate this. So we would say like 7, and then more than will become plus. Twice means 2 times, and then wooden is x. Okay, so you see that's how you turn that into that equation, y equals 7 plus 2 times x. Okay, like I said, very mathematical sentence. And then it says he has 22 plastic trains. So that actually just gives us the value of z. Okay, so we know that he has 22 plastic trains in his collection. So if we write all three of our equations together, this is what the system looks like. We have x plus y plus z equals 200, y equals 7 plus 2x, and z equals 22. So remember that many real-life situations can be modeled by a 3x3 system. So when setting up these problems, be sure to read each problem carefully and define your variables before setting up equations to represent the situation.